Hi there, everybody. This is lesson 2.3.2. It's called the triangle inequality, and this lesson's about answering one question in particular, and it's can you make a triangle with any three side lengths? Here on the page, you see some side lengths here. Can I make a triangle that is 3 centimeters on one side, 5 centimeters on another side, and 10 centimeters on the other side? But in general, will any three side lengths form a triangle? To investigate that, we're going to look at another program here. So 3, 5, and 10 is the first one we want to test. So let's change these side lengths here. And there is 3, 5, and 10. So I'm going to kind of move this stuff around a little bit. So here's, again, we got this one is 3 units long. This one here is 5 centimeters long. And this longest one is 10. We're going to try to make a triangle with it. Okay, so let me move things around here a little bit. Uh-oh. Yeah, let's see here. There we go. And I'm going to try to move this top point down. Am I going to be able to make a triangle out of this? I don't think so. I don't think 3, 5, and 10 is going to work. These two sides here, these two shorter ones, 3 and 5, just together aren't long enough to get to the other end of that 10 centimeter side. They're just those smaller two of the two aren't big enough. So let's so the 3, the 5, and the 10 don't work. Let's look at 4, 9, and 12. Change these. There's 4, 9, oops, 11.9, we want 12. There we go, 4, 9, and 12. Okay, so let's see if we can make a triangle with these three side lengths. And it looks like that is going to work. Sure enough, it does. We can make a triangle with four sides that are 4, 9, and 12. And as you can see, we talked about the two smaller ones in that last example. The 4 and the 9 together are longer than this third side. So we were able to kind of connect one side of this 12 centimeter segment to the other because the shorter two were together bigger than 12. So let's see, the 4, 9, and the 12 did work. Let's look at 2, 4, and 5. See if that will work. So we've already got one that's 4. Let's change this one to 2. And this one to 5. Let's see here. The green one, I'm leaving the longest in all these examples so we can kind of keep track mentally of which side length is the longest. And that's, looks like 2, 4, and 5 are going to work. And again, we can see these two shorter sides together are longer than the longest side. And so they're able to go from one end of the longest side to the other. Because together, 2 and 4 is bigger than 5. Because 2 plus 4 is 6, of course, and 6 is bigger than 5. So that one worked as well. 2, 4, and 5 did work. Let's check 3, 5, and 8. Again, keeping the green one the longest. There's 8. What do you think is going to happen here with 3, 5, and 8? Do you think 3, 5, and 8 are going to make a triangle? Now that you've maybe made a guess, let's see what happens. See, 3, 5, no, not quite there. Whoops, I want to do that. 3, 5, 8, no, aren't quite matching up yet. Let's move this a little more. Well, there we go. They do match up, but that doesn't look like a triangle to me. That looks like a straight line. And we look at the smaller of the two sides. They are 3 and 5 units long, and together they are just exactly as long as this side as the longest one, that's 8 units long. And so they're not big enough to form a triangle. Okay, they will connect one end of that longest side to the other, but those smaller sides have to be on top of the biggest one. That doesn't make a triangle, that makes a straight line. So 3, 5, and 8 do not work. Now, hopefully, as I've been explaining this, you realize that in order to make a triangle, the two shorter sides must be, must add up to more than the longest side. That's how we can tell whether 3 side lengths make a triangle. We can test it with these that we've already seen up here. The two shorter ones here are 3 and 5. 3 plus 5 is 8, but 8 isn't bigger than 10, so that one didn't work. The two shorter ones here are 4 and 9. 4 plus 9 is 13, and 13 is bigger than 12. So these 3 side lengths will make a triangle. The two shorter ones here are 2 and 4. 2 plus 4 is 6, and 6 is bigger than 5. So this one will work. The two shorter ones here were 3 and 5. 3 plus 5 is 8, and 8 is not bigger than 8. 8 is equal to 8, but it has to be bigger. Not equal to, but bigger. So 3 plus 5 again is 8. 8 is not bigger than 8, so this one did not work. So let's go on to the next part here. Here I've given you two side lengths, 5 and 12. And I want to know kind of what range of numbers could be the third side of this triangle. So let's test some values here. Let's say we want to know if 2 works. Well, if the 3 sides are 2, 5, and 12, the smaller ones are 2 and 5. If you add those together, that makes 7, but that's not bigger than 12. So 2 won't work. Let's try 3. So if the side lengths are 3, 5, and 12, the two smaller ones are 3 and 5. 3 plus 5 is 8, but 8 isn't bigger than 12. So again, 3 will not work. Let's try 4. 4 plus 5 is 9. 9's not bigger than 12. That will not work. What about 5? The two smaller ones would be 5 and 5. 5 plus 5 is 10. 10 is not bigger than 12. 5 won't work. Let's try 6. The two smaller ones would be 5 and 6. 5 plus 6 is 11. 11 is not bigger than 12. 6 won't work. Let's try 7. The two smaller ones would be 5 and 7. 5 plus 7 is 12. But 12 isn't bigger than 12. 12 is equal to 12, but not bigger than 12. So 7 will not work. What about 7.001? The two smaller ones would be 5 and 7.001. 5 plus 7.001 would be 12.001. And that is a little bit bigger than 12. So this will work. And as long as it's just a hair bigger than 7, it could be 7.000000001. Okay? As long as it's a little bit bigger than 7, it will work. Let's try some other values here. Let's try 8. 5 and 8 is 13. 13 is bigger than 12. That'll work. Let's try 9. 5 and 9 is 14. 14 is bigger than 12. That will work. Let's try 10. The two smaller ones would be 5 and 10. Add them up, you get 15. 15 is bigger than 12. That'll work. About 11. 5 and 11 is 16. That's bigger than 12. That'll work. What about 12? Well, there isn't really two smaller ones. If it's 5, 12, and 12, there isn't really two smaller ones. So we've got to take one of the 12s and the 5. So 5 and one of the 12s is 17. And 17 is bigger than 12. So 12 will work. Let's try 13. Now 13, if the sides are 5, 12, and 13, the two smaller ones now are 5 and 12. Because 5 and 12 are smaller than 13. Let's see, 5 and 12 is 17. That's bigger than 13. So 13 will work. And maybe you say, you know what? These are going to be bigger. 5 and 12, if you add them up, they make 17. So all the numbers up through 16 are going to work. Because 5 and 12 is 17, and that's bigger than 16. But will 17 work? What about 18, 19, and so on? Well, 5 and 12 is 17. That's not bigger than 17. So actually, 17 won't work. 5 and 12 isn't bigger than 18. 18 won't work. 5 and 12 isn't bigger than 19. That won't work. And all the numbers bigger than 19, none of those will work either. So those are the values that will work. Numbers that are bigger than 7 and numbers that are less than 17. So the question is, how do we get these numbers here without going through this whole process that we went through? How do we get 7 from 5 and 12? How do you get 17 from 5 and 12? Well, hopefully you recognize that when you subtract 5 and 12, you get 7. 12 minus 5 is 7. How do you get 17? Well, hopefully again you recognize that you add these. 12 plus 5 is 17. So what we say here is that if two sides of a triangle are 5 and 12, the third side has to be between 7 and 17. Now, it cannot be exactly 7. It has to be between them. It can't be 7, can't be 17. It has to be between them. Okay. Another way to write this, and this is one that you should look familiar to you from algebra. If we call the third side x, it just means that x has to be bigger than 7 and smaller than 17. It's just kind of another way to say between 7 and 17. And make sure you know how to write that. Okay. So that is our lesson today. Hope you guys have a great day. We'll see you in class tomorrow. Bye.